We'll now start to talk about angles. The definition of an angle is the set of points belonging to each of two rays that have a common endpoint. So the idea is we have these two rays and they share their endpoint, like this. The actual rays themselves are called sides. And this common endpoint that they have is the vertex of the ray. There are two special types of angles that we will consider. Degenerate angles are angles where their sides coincide. So it just has a single side since the sides are the same. While I haven't defined angle measure yet, you can think of this as being a 0-degree angle. The other special type of angle is a straight angle, and this is where the sides are opposite rays. Once again, I haven't defined angle measure, but we can think of this as a 180-degree angle. Now that we've defined an angle, let's look at some notation for angles. Here's an angle. I have two rays, which I denoted by H and K. A is the vertex, B is some point on ray H, and C is some point on ray K. There are going to be three ways we can refer to this angle. We can refer to it as angle BAC, or equivalently CAB. The main thing is the vertex point is the one that needs to be in the middle. If it's not ambiguous on which angle we're talking about, we could just call it angle A. And we can also refer to it as HK with a line over it. So this refers to the angle formed by rays H and K. We can also talk about the measure of the angle. We can refer to the measure of the angle as MBAC, where the M stands for measure. So this is measure of angle BAC. Equivalently, we could write the measure of angle A. And finally, we can write HK with no bar. So the bar over it means that we're talking about the actual angle, and no bar means we're talking about the measure of the angle. While I'm talking about the measure of the angle here, I haven't actually properly defined this based on just my axioms. So far, we have axioms 0 through 6, and none of them refer to angles. So I need a core way that we can define how to measure an angle. Our angle measures are going to come from two axioms, the first of which is axiom 7. Axiom 7 states that for every angle HK, there's a real number, which I'll call HK without a line, that's called its measure, such that two properties are satisfied. The first property says that the angle measure is greater than or equal to 0, with equality if and only if H is equal to K. So this says that angles will always be greater than or equal to 0, and the only time it's equal to 0 is in that degenerate case, where the two rays coincide. Other than that case, it will be a positive number. And the second property says that the measure of angle HK is equal to the measure of angle KH. This essentially says that it doesn't matter if I measure angles clockwise or counterclockwise, they should be the same. While this does give us a lower bound for our angles, in particular 0, it does not give us an upper bound. And that's actually going to come from axiom 8. Axiom 8 says that the measure of an angle is less than or equal to the measure of any straight angle. So the straight angles are the largest possible angles that we can have. For our purposes, this will be 180 degrees. If you're talking about radians, then this would be pi. But essentially, it's the measure of a straight angle, and that'll be the largest it can be. We are going to deal with degrees. So essentially, between these two axioms, I've stated that all angles are going to be between 0 and 180 degrees. Now that I've defined the measure of an angle, I can talk about betweenness for rays. We say that a ray U lies between two rays h and k, denoted by this HUK in parentheses, provided two things are true. The first thing we need is that HK and U are concurrent rays. So this just means they all have a common endpoint. The other condition is that the measure of the angle between rays H and U plus the measure of the angle between rays U and K is equal to the measure of the angle between H and K. Let's expand this idea to 4 rays. So now I have H, K, U, and V. So let's suppose we have 4 conditions. K is between H and U, K is between H and V, U is between H and V, and U is between K and V. Then I can refer to H, K, U, V. And I need all 4 of these because I don't want to go beyond 180 whenever I measure any one of these. So we can have H, K, U, and V. And if I try to drop one of these, it is possible for this not to hold because I may go over 180 degrees, in which case I would have to measure the other way around, which would break my betweenness.